In this video, I want to show you how we can move something into polar coordinates once we're given some kind of region. Once we can describe a region, we can convert it into a different form. I want to move this one from things in x, y. I want to move them into terms of r and theta. So how do we do that? Well, first I'm going to sketch the region so that we can really see what's going on. The y values are going to be going from 0 to 1. I just found that by looking at this outer part, and I'm going to do the same kind of reasoning for the x. The x values are associated with the inner part, and that's going to go from y to the square root of 2 minus y squared. Okay, well, what does that look like? Well, just notice that this right here, the upper bound for x is just going to be the same thing as a circle with radius 2, or square root of 2, by using a little bit of rearranging. So we can really just draw the circle then. And I'm going to say that that has a radius of the square root of 2. So we already found the r part, and the other function is going to be the function y equals x. Okay, so now I'm going to sketch the region now. Now that we have all of our functions on the graph right here, I'm going to say that for any y value that I pick, well, y values are going to go between 0 and 1. For any of these that I pick, I'm going to pick this one. Say it's 1/2. I'm just arbitrarily picking points, and I'm going to show you how far out I can go. Well, the x values, they can only go between two functions. They can go between the function y and the function the square root of 2 minus y squared. But I just showed you that this was the outer edge of the circle, so I'm going to draw a line increase. I'm going to start from the lowest one, and I'm going to go to the highest x value, which is the outer edge of that circle. So if I were to use all the infinite amount of points, you would believe me that drawing each line would indeed eventually shade this whole region right here that I just described from 0 to 1 and the function y to the function of the outer edge of the circle with a radius of square root of 2. So now that we have that, we need to convert that to polar coordinates. One way that we can do this is by saying, well, theta's got to go between this right here and the r values. Well, the r values are going to shade this region in a different way when we use the infinite. Instead of going across like that, functions that are of the form r theta, polar functions, I don't know what you call them, they start from the origin and they go to the outer edge of a circle, like this. So all we have to do is find out what this point, I'm going to draw it in a different color, we need to find out what this point is, because that's as far as we can go up as far as theta goes. So we already know our r value. The r values are pretty obvious. They're going to go from 0 to the square root of 2. But the theta is a little less obvious, even though it's pretty easy to figure out. Well, I'm just going to say that this point right here of x comma y can be described, well, my motivation for doing this is that this inner theta, which is constructed by this right triangle, is going to be the same as our bound for theta. And, well, we can solve by knowing that our triangle will be this. Since x and y, this was the function y equals x, we know that any right triangle is going to be a 45, 45, 45, 90 triangle, which means that these legs are going to be equal to each other. So in order for us to have this triangle exist, the legs have to be 1 and 1. So 1 is equal to x and y. So that means that theta is going to be the tangent inverse of 1, which equals pi over 4, which equals 45 degrees. So now we figured out what the ranges for theta are. They go between 0 and pi over 4. So now we have all of the information to describe this integral up here. And we can convert it into that form. So how do we do that? Well, first we have to take our value, or our knowledge of these two identities, and we need to put them in for x and y. Well, earlier it was just x comma y, but now I'm saying that it's our cosine theta, our sine theta, and our dA is going to be r dr d theta. Or that's dA. And our thetas are going to go from 0 to pi over 4, and our radii are going between these two values. So that's the final answer, and I hope that gives you a little bit of clarity how to make sense of regions that are described in terms of x and y, and then how we can describe them with r's and thetas. If you have any questions about this, or if I wasn't clear about something, please send me a comment, and I'd really like to respond to you.